Okay, here are the other 4 problems that are on the back. Some of these have got a little bit of work to them, and I really like problem number 5. In fact, I might use a problem like this sometime in one of my classes. I originally tried to work problem number 5 with 2 variables. We are looking, it says a hot air balloon, that's supposed to be my picture of a hot air balloon up there, is hovering over Valley Forge. So that means if I come straight down and form a right angle, here's Valley Forge, right here, Valley Forge. Now it says here that person A views the balloon at an angle of elevation, he's looking up here, of 25 degrees. Now notice it doesn't give it, the measurements are not marked in this diagram, so you have to put those in, while person B, that's over here, views the balloon at an angle of 40 degrees. So you can see this is not drawn to scale. Sorry about that. Okay, and it says if A and B are, that's these 2 guys, are 4,000 feet apart, okay, find the height of the balloon, which I'll just go from here down to here. That's the height right there. Now, if they had given you a different side besides this one, if they'd given you this side, or especially this side, or this side, you could probably do this a lot faster. But here's how I went about to do this problem. I used the law of sines because I had angle, side, angle, and of course if I know these 2 angles, they add up to 65. That means this angle here would be 180 minus 65, or 115 degrees for the whole angle there, up there. So that comes in handy because now I have the angle on the opposite side, so I can use the law of sines. Now you say, well, what are you using the law of sines for? Well, I'm using the law of sines so that I can find one of these 2 sides here. And I'm going to find this guy right here. I'm going to find the side that's opposite angle B. Boy, I just thought of an even faster way to do this. So I'm going to take the sine of 115 degrees, and I'm going to put that over 4,000, and I'm going to set that equal to the sine of 40 degrees, and I'm going to put that, just call this x for right now, all over x. So I'm using the law of sines here, cross multiply, I get x times the sine of 115 is equal to 4,000 times the sine of 40. So I'm going to divide both sides by the sine of 1015 degrees. And I get x is equal to what this mess turns out to be. And this mess turns out to be 2836.9506. Of course, that's an approximate. 2836.9506. So that's this guy right here. Now the reason that I'm taking him is now, look at the right triangle that's to the left. I'm trying to cover up the right triangle on the right. I'm going to use Sohcahtoa because I am looking for the opposite side, the opposite of angle 25, and I now have the hypotenuse. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's my guy. See, if I kind of erase this here, I'm just going to kind of mark it out. Do you see I have the angle, I'm looking for the opposite side, and I now have the hypotenuse. So I'm going to write that the sine of 25 degrees is equal to h over this number. And I'm going to go ahead and write it out. I'm not going to round it yet. I'll get there. I'm going to multiply both sides by that. I get h is equal to 2836.9506 times the sine of 25 degrees. Now, I grabbed my calculator because I did it a different way the first time I did this, actually the second time I did this, and I'll make sure that I match my answer. So I'm going to take 2836.9506 times the sine of 25 degrees. Okay, and I get this to be 1198.947, or to 2 decimal places. I get the height of the balloon, is 1,198.95 feet. There we go. Now let's see if I match it when I worked it the other way. And I did. I got the same answer, so that's kind of cool. More than one way you can work this problem, but I would start it this way no matter what. This is the third example of an application where I had to find the third angle. They gave me two angles. I found the third angle and set up a law of sines. Now, my drawing isn't very good, but you have three circles that are tangent to one another, and they represent circular tracts of land. And the diameters are given. It says here that the houses are directly at the center of each circle. Now remember, it says the circles are tangent to each other. That's important. It says the houses are directly at the center of the circle, so that's the three houses right there. What are the angles of the triangle connecting the houses, and what's the area of the triangle? This one's got a lot of work. So you call this house House A, this house here House B, this here House C. I think that's what I did the first time I did this. Let me see here. Yeah, I got A right. B, I used. Yeah, I think I got this to match the first time I did this. Now, here's the deal. When you draw a diameter to the point of tangency, it is perpendicular to the tangent line. So these are both perpendicular to the same tangent line. That means this guy goes straight through here, and the diameter of the first one, the big circle, is supposed to be 900 meters, the diameter, so that means that the radius, here I'm going to use a different color. Hopefully this will be something you can see. The radius is 450, half of 900. So this is 450, and this is 450. And this is in meters. Alright, so now the second biggest one, it has a radius of diameter 700 meters, so that means this is half, this is 350 meters, this is 350 meters. And then the last guy there, I'll use pink, it has a radius of 600 meters, so that means this distance is 300 meters, and this distance is 300 meters. Now, you look at that and you say, what a mess. Well, here's what I would do. Draw the triangle. It doesn't have to be perfect. ABC. And look what you have here. You have a cross from B to C, 300 plus 350. This is 650 meters. From A to C, you've got 450 and 350. This is 800 meters. And from A to B, you've got 450 and 300. This is 750 meters. You know the three sides of a triangle, and you're trying to find the three angles. So, law of sines. This is an easy one. Now, the law of sines, for a problem, let's say we're going to find A here, angle A, would tell me that this side would be A, this side would be B, this side would be C. It would be something like A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Well, I showed you another way to do this, but you can use this. But the other way to use this is this form, cosine of A is equal to B squared plus C squared minus A squared all over 2BC, because you've already got the variable practically that we're solving for, angle A, practically by itself, just got the cosine of it. So if I use this and say the cosine of A is equal to B squared, which would be 800 squared, plus C squared, which would be 750 squared, minus A squared, which would be 650 squared, all divided by 2 times 800 times 750. Now I did this on my calculator, and I got this to be, it turns out to be exactly 0.65, which is kind of remarkable. So 0.65, then would be the inverse cosine of 0.65, and I got A to be 49.46 degrees. Now I think he rounded it to the nearest tenth, although the directions I don't think asked for it. He rounded it to the nearest tenth. I'm just being consistent with the other problems. I'm taking it out 2 decimal places to the hundredth. And then I find the cosine of angle B in a very similar manner. It would be, for cosine of B, it would be A squared plus C squared minus B squared. Notice A, B, B here on the ends, all over 2AC. These two letters, these two letters, these two letters, these two letters. You got to memorize them, and you can take advantage of knowing this. It'll make the problems work a little bit easier. So for B, I get 750 squared plus 650 squared minus 800 squared all over 2 times 750 times 650, and I got this to be approximately, this one didn't come out quite as nice, 0.3538. 4 places is plenty good. So that means B is equal to the inverse cosine of 0.3538, and that means angle B turns out to be 69.28 degrees. Now, you don't have to go through it a third time because you already have 2 out of the 3 angles. If this guy is 69.28 degrees and this guy here is 49.46 degrees, then you add these two, subtract from 180, and when I did this, I got C to be 61.26 degrees for angle C. Again, add these two and then subtract from 180. So now I have all 3 angles, and now they also want the area. Well, I have all 3 sides, so I'm going to use Heron's formula, and I'm going to say, first off, that S is A plus B plus C divided by 2, so it'd be 650 plus 750 plus 800 divided by 2 turns out to be 1100 if I haven't messed up. So that means the area is equal to the square root of, using Heron's formula, 1100 times 1100 minus 650, 1100 minus 750, 1100 minus 800. And I got my calculator busy and I did this and I got 227,980.26, and this would be in square meters because it's area. Now I know it's a story problem, but it doesn't, what are the, you could say, and I'm really out of space here, so I'm going to kind of run it over here. As far as answering it in a story or in a sentence, you could say the angles of the triangle connecting the houses are, what did I just say, 49.46 degrees, 69.28 degrees, and 61.26 degrees. The area, I gotta spell it, of the triangle is, down here, 227,980.26 square meters. So that's a lot to write out, but that's how you would go ahead and state it, something like that there for problem number 6. Now as you can see, I used some of the room here for problem 7. Fortunately, problem 7 doesn't take all that long to figure out, but I may have to erase some of this. So look that over. Of course, you can always rewind. So it says, because of prevailing winds, a tree grew so that it was leaning 6 degrees from the vertical. So that's this angle right here, 6 degrees. Little bitty guy there. This dotted line is supposed to be perpendicular to the ground, which I've drawn the right angle for. This line segment down here from P to A being the ground itself. Now it says here that at a point 100 feet from the tree, that's point P, the angle of elevation to the top of the tree is 22.8 degrees. You're to find the height of the tree, so I called it H. H is the height of the tree from A to T. So I can do this, but I have to have 2 sides at least to do the law of cosines. I only have 1, so I'm thinking law of sines again. I don't really have a right triangle to find this side here, find H. So I'm not thinking Sohcahtoa, I'm thinking law of sines. This is 22.8. This part here is 90 plus 6 more means all of this would be 96 degrees. All of this would be. So if that's 96 and that's 22.8, add those together, subtract from 180, this angle up here, angle T, turns out to be 61.2 degrees. And notice I have the side opposite the angle. I needed that ratio. So I'm going to write the sine of 61.2 degrees is to 100 as, now I'm trying to find H, it's opposite angle 22.8 degrees, angle P. So I'm going to say the sine of 22.8 degrees divided by H. Cross multiply H times the sine of 61.2 degrees is equal to 100 times the sine of 22.8 degrees. I'm going to divide both sides by the sine of 61.2 degrees. And I get h is equal to, now I did this on my calculator and I got this to be about 44.22, and it says find the height of the tree. Well, that's h, so the height of the tree is 44.22 degrees. And that's problem number 7. One more to go. Problem number 8, they gave you this drawing. The dotted lines are supposed to be going straight up and down, like going to north. It says 2 fire towers at points A and B here are 18.5 miles apart. The bearing from A to B, all right, now the bearing is the angle, the acute angle from the perpendicular from the north to the south going to the east or to the west. That's 65 degrees there. That's the bearing from A to B, is 65 degrees. Okay, it says a fire that has a bearing of N28 point E from A. Here's the fire over here. Now point B was one of the towers, fire towers. These two are fire towers, but there's the fire. And it says that the bearing from A to the fire is 28 point, or is north 28 east. So that means from due north 28 degrees in the eastern direction. So it's this angle right here. And what else do we know? We also know that the same fire was spotted by a ranger in Tower B, and it had a bearing of north 16.5 west. So that means this angle here from due north, 16.5 degrees west of due north, that's this angle right there. And we're to find the distance of the fire from Tower A. So that would be this. We'll call it X. All right, well, let's see what we have here. We have, okay, we have, this is 65 degrees here. Now these are both vertical lines. This is a transversal. That means this angle here is 65 degrees. This is 16.5. We don't know this one. But this is 65. But all three of these have to add up to 180 because they form a line. It's not really a linear pair. It's like a linear triple almost. So if I add the two that I know, that would be 81.5. And then subtract from 80, I get 98.5 for this guy right here. Angle, kind of angle B here with the dotted arc right there, 98.5. I know that's messy. And look right here. I don't know this angle, but I can figure it out because this angle minus this angle would give me the angle in question from point A. So 65 minus 28, 45, 37 degrees. So now I know 37, I know 98.5, sounds like a radio station on the FM. I add those together, subtract from 180, and I got this to be 44.5 degrees. So see, I need that angle because it's opposite that side. If I'm going to use the law of sines, and I have to use the law of sines, it's not a right triangle. I can't use Sohcahtoa. I can't use the law of cosines because I need at least two sides given, and the angle in the middle of them, or all three sides. So in this case, the law of sines tells me that the sine of 44.5 degrees is the 18.5 miles as, now I'm trying to find x, so I'm going to use the 98.5 angle, the sine of 98.5 degrees, all over x. And I'm solving for x, so I cross multiply. X times the sine of 44.5 degrees is equal to 18.5, multiply this way, times the sine of 98.5. Okay, I divide both sides by the sine of 44.5 degrees. Kind of nice. I don't think I ever really had to figure out an angle. Or if I did, oh yeah, back here with the law of cosines, that wasn't so bad. So I have x is equal to, what does that turn out to be? 26.104, so to 2 decimal places, the distance of the fire from Tower A is 26.10, 2 decimal places, it rounds to 0 there, miles. And that's the answer there to that one. Now, some pretty good problems, and if your test is coming up in 2 days, after you get done with this, you need to start working on all the stuff that you were working on for the quiz that was supposed to be today, and this stuff as well. Make sure you have all the key formulas memorized. I don't know if he's going to be like this worksheet and give you all the key formulas right at the top of the paper. That'd be cool. It'd also be really cool if you knew not only this version of the law of cosines, but this version of the law of cosines, because of the convenience of finding angles. So study, 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 and ask me questions if you are unsure.